revision series, another mathematics session today, and we are talking for the second time about short division. I have got another video about short division, and that should tell you the basics of when we're dealing with a one-digit divisor. So how we usually see our bus stop method, we have a single-digit divisor, and that's what we're used to seeing. We needed to get the basics of that correct. In that other video, I talked to you about creating a toolkit to make sure that you never drop a mark in those questions. So go and have a look at that one if you haven't watched that first, or if you feel like you need a refresher of the general methods. Lottie's here ready for double-digit divisors as well. She's excited and you should be too. Again, same points as my original video. Fundamental to all mathematics, you're going to get division questions in every arithmetic paper, and they're going to form, well, they're one of the four operations: multiplication, addition and subtraction, and you're going to be using this skill all the time. So it is key to get this right, and it will, understanding this will get you marks in all kinds of papers and is relevant to everything. So do spend time learning this. I mean, spend time learning everything, but focus on the basics so we get those right. My memorable / annoying line is don't forget your toolkit. I explained it in the other video, but I will give you examples in this video as well. Let's go straight into some examples because that really will demonstrate things much more easily. So question 13 here, 1,210 divided by 11. First things first, I'm going to, in a very scruffy manner, rewrite this. I would use a ruler. And in order to get this correct, I'm going to use my toolkit. I'm going to write down my 11 times table over here. So 11, 22, 33 and onwards. Simplest times table to remember, still useful. So first thing to remember is when we're dividing and we're trying to see whether we can fit a double-digit number into a single-digit number, it's never going to work. So we have to be talking to ourselves and saying, how many times can I fit 11 into 1? It's always going to be 0. I'm going to exchange that one over there to make this 12. All right, lots. How many times can I fit 11 into 12? 1 time. And the extra I have is 1. How many times can I fit 11 into 11? Once, and a 0 at the end. And my answer there is 110. It doesn't matter if you put 110 or 0110, it's still going to get the mark. That one is a single mark, which I think is possibly a little bit harsh because you've still had to do a toolkit and it's still a double-digit divisor as well. Here is an example of a much more fussy one. So we have got 2 marks on the bottom there. It is 3,066 divided by 73. So the major work is going to be in building my toolkit. That's going to be the hard graft. So 73, I'm basically got to write down my 73 times table. 73 times 1 being 73. I can double it relatively easily. 146. And now I don't want to make a mistake. So I'm going to write 146, add another 73. 6 and 3 is 9, 4 and 7 is 11, and then 1, add nothing, add 1 is 219. So it's my third. That's 73 times 3, and then I should be able just to add this on relatively easy. So add a 3 onto there, making 222, 292. There we go, 292. And then because I'm going over the 300 barrier, I'm going to do another quick column addition here. 2 add 3 is 5, 9 add 7 is 16, 365. Hoping that'll be enough because I don't want to spend too long building the toolkit. 5 or 6 elements, 5 or 6 times 73 will probably be fine. So let's go then. 73, how many times does 73 fit into 3? It doesn't, it's always going to be a 0. Exchange the 3. How many times does 73 fit into 30? Also a 0. Exchange the 30. Bring the whole lot along. You've done nothing with this 30, so you move the whole lot over. This is now 306. How many times does 73 fit into 306? Well, 73 once, twice, 3, 4, but not 5. So it fits in 4 times, and we get to 292. Our target was to get to 306. We got to 292. Now I can count this on. Could do it in a column subtraction. Leave a 4 there. 2, 1, 14. But I could also count it up. So if I got to 292, what's the difference between 292 and 306? Well, 8 more gets us to 300, add another 6 is 14. So I now know I need to exchange, I need to deal with that 14. I've got a final answer here of 146. So I'm looking over to my toolkit, and helpfully it is the second element there. Second one, 73 times 2, that's 146. 42 is my answer, 2 marks gained. Now another tip, I'm not saying this will never change, but it hasn't changed so far, is that you don't seem to get remainders on double digit division. I don't know whether the exam boards think it would be too tricky to have remainders and a huge toolkit over here. It always finishes in a nice round number. So that was the second element there, 42. If you've got a remainder, I would check your answer and just see whether something's gone wrong somewhere, because it can happen. So my answer there is 42. I've done everything I needed to, and even if I did make a slight error somewhere, I think we've got enough here with the toolkit, the column addition, and showing our working to at least get 1 mark, even if we did happen to make a small slip up. We want to come away with this with something. Don't try and do it in your head. A final example just to illustrate the point, not actually as tricky as the other one, but the more we drill this, the easier it will be. So 43, we're going to do a 43 times table. Next element's 86, and then we're going to add another 43, make it 89, 1, 2, 9. And whenever you feel like, oh, I'm just not sure, do a column addition, because you're much less likely to make an error. 9 add 3 is 12, 7. There you go. So you got 172. And then, oh yeah, because I'm going over the 200 barrier, I'm going to do the same thing. 172, add 43, there's a 5, there's an 11 there, 215. Probably just do this 5 elements, see how far we get. Same thing applies. How many times do we fit 43 into 6? We don't. Exchange the 6. How many times can we fit 43 into 64? 1 time, but as we can see over here, we can't fit it in twice. So our target number is 64, and we only have 43. So what's the difference? When we subtract, working out the difference, 4 taken with 3 is 1, 6 taken with 4 is 2. So we have to exchange 21, making this final one 215. How many times does 43 fit into 215? Once, twice, 3 times, 4 times, 5 times. Again, no remainder, and your answer is 15. I've just written this on the outside of the answer box, but if you can fit all your working out in there, that's great. And that will be me giving myself 2 marks for that, well done me. The key things to remember are, treat these questions like any other short division. Just because it's got a 2 double-digit divisor, don't be scared of it. You just write your toolkit like you would do with a single, and use your toolkit every single time. Also, but I can't promise this, you shouldn't get a remainder. So you're looking for a nice round number. This one finished with 15, the other one finished with 42. You're not expecting a remainder. So if you get one, have a look through, look at your column additions. Okay, did everything go right there? Check this through and make sure that this toolkit is bulletproof. That's the hard work. Every single time, the toolkit is the hard work, and then you're just laying it out as best you can. So hopefully that's helped you with double-digit short division. At least a key stage 2 level, you will not get a more tricky question. Probably this one, really. A 73 times table is a bit nasty, really. But again, it's applicable and useful to everything in mathematics. So do let me know if this video has been useful to you. What other topics you'd like to know about? Comment down below, like, subscribe, all of that stuff, and I'll continue to make videos. I'm on a bit of a math streak at the moment, but let me know what you need to know, and I will make videos for you. See you soon. Ciao.